In 1988, a woman named Patricia Kowalski bought a Maytag dishwasher. It had a stainless steel tub, a cast metal pump, and a rotary mechanical timer with physical gears. No circuit board, no soil sensor, no Wi-Fi. Just metal and water and a motor that knew one speed: on. Patricia's dishwasher ran for 23 years before she replaced it. Not because it broke, but because she remodeled her kitchen and wanted something quieter. The machine she replaced it with died in 6 years. The one after that died in 5. And the one sitting in her kitchen right now, a $900 Energy Star certified machine with a touchscreen and a soil sensor and a 3-hour wash cycle, is already throwing error codes. This is not bad luck. This is the business model. We have spent the last several months pulling apart the numbers on residential dishwashers, the Consumer Reports reliability data, the Department of Energy regulatory filings, the class action lawsuits, the CPSC complaint databases, and the repair statistics from service centers that see these machines every single day. What we found is not a conspiracy. It is something more mundane and more infuriating than that. It is a system, a legal, government-certified, industry-approved system that is designed to sell you a machine that cleans your dishes for 5 to 7 years, then dies in a way that cannot be repaired at a price that makes repair rational, forcing you back into the store to do it all over again. And the label on the front of that machine, the Energy Star sticker that every appliance salesperson points to as proof of quality, is the centerpiece of the lie. Here is what that label actually measures. It measures how many kilowatt hours your dishwasher consumes per year during operation. It measures how many gallons of water flow through each cycle. That is all it measures. It does not measure how long the machine will last. It does not measure whether the circuit board will survive 5 years of steam and heat. It does not measure whether the plastic sump housing will crack under the stress of running low water cycles 10,000 times. It does not measure whether you will spend more money replacing this machine twice in 10 years than you would have spent buying one good machine and running it for 25. The Department of Energy tightened the standards in 2010 to 355 kilowatt hours per year and 6.5 gallons per cycle. Then in 2013, the standards were tightened further: no more than 5 gallons per cycle, no more than 307 kilowatt hours per year. Then, in 2012, Energy Star pushed its certification threshold further still: 4.25 gallons per cycle. For reference, a dishwasher from 1985 used 10 gallons per cycle. The engineering problem is straightforward. Less water means less mechanical cleaning action. Less mechanical cleaning action means the machine runs longer to compensate. Longer run times mean hotter control boards and faster component degradation. And fewer gallons of water means the food debris that used to be diluted and flushed away is now sitting in a concentrated slurry at the bottom of your tub, grinding against a plastic pump housing that cost the manufacturer $4 to make. They call it Energy Star certified. We call it a machine that takes 3 hours to do what your grandmothers did in 45 minutes and dies at year 5 doing it. This is not innovation. This is regulatory compliance dressed up as progress, sold to you with a sticker and a touch screen. Now, let us open the machine up and look at what is actually inside it. Start with the control board. In every dishwasher built before 2007, the brain of the machine was mechanical: a rotary switch with physical gears, metal contacts, and a timing motor. It cost the manufacturer between $10 and $15. It could survive a decade and a half of heat and humidity because there was nothing to corrode, nothing to swell, and nothing to short out. When it failed, which was rare, a repairman could replace it for $50 in parts and labor. The machine kept running. In your current dishwasher, the brain is a printed circuit board, FR4, epoxy, surface-mounted electrolytic capacitors, resistors soldered by machine at a factory in China. It costs the manufacturer between $2 and $5 to produce. It is located behind the front door panel, inches from the steam and moisture of every wash cycle. Every time that machine runs, the board heats up. Every time the cycle ends, it cools down. Heat, cool, heat, cool. 100 times a year, 400 times over 4 years. The solder joints micro-crack. The electrolytic capacitors absorb moisture and begin to swell. The copper traces oxidize. And then one morning, You push the start button and nothing happens. Or the machine starts beeping and flashing an error code and will not stop. Or it fills with water and will not drain. Consumer Reports surveyed more than 66,000 members about more than 77,000 dishwashers in 2024. Control board failure was among the most commonly reported causes of premature failure. Miele Appliance, one of the most respected independent appliance retailers in the country, reports that a substantial portion of all dishwasher service calls in their data are attributed to control board failure. The board that costs $2 to manufacture will cost you $250 to $300 to replace, if you can find one, if the manufacturer still makes it, and if the repairman can get it. Add $150 in labor. On a $700 machine, the repairman looks at you across the kitchen and says those 5 words. It is not worth fixing, but the control board is only the beginning. Now, look at the pump and sump assembly. This is the component at the bottom of the tub that grinds up food waste and pumps the dirty water out. In every pre-2007 dishwasher, this was built from cast metal or porcelain. It cost $12 in materials. It could survive 20 years of daily use because metal does not fatigue under thermal stress. Metal does not crack under vibration. And metal does not warp when the water flowing through it is reduced to a fraction of what the component was designed to handle. Today, that assembly is injection molded ABS plastic. It costs the manufacturer $4. Under the new low water standards, the machine is pushing concentrated debris through that plastic housing 10 times for every cycle. Debris that used to be diluted and carried away with 10 gallons of water, now grinding through on 4. The plastic fatigues. It develops micro cracks. Those cracks grow. And somewhere between year 4 and year 7, the sump housing fractures in water starts appearing on your kitchen floor. The Consumer Product Safety Commission database shows more than 15,000 sump-related complaints between 2018 and 2025. Not 15,000 isolated incidents. 15,000 households with water on the floor, potential cabinet damage, potential subfloor damage. The plastic sump assembly that caused the problem costs $4 to manufacture. The replacement part costs you $90 from the manufacturer's parts supply because they control the supply chain and they price accordingly. Add $300 in labor, and you are still staring at a machine that is almost certainly going to have a control board failure within the next 2 years. It is not worth fixing. Now, look at the tub itself. Before 2007, the interior of a dishwasher was stainless steel, not the decorative stainless on the door. The actual tub, the walls and floor where your dishes sit, was stainless steel. It cost $50 in material. It did not rust, it did not crack, it did not leach chemicals under heat. It ran for 25 years. Today, in 90% of machines at every price point below $1,000, the tub is a polypropylene plastic liner less than 1 millimeter thick, wrapped in sound-deadening foam to meet the Energy Star noise requirement of under 50 decibels. It costs the manufacturer $20. Over time, repeated exposure to alkaline detergents and the thermal cycling of hundreds of wash cycles causes the plastic to embrittle. The door gasket, made from EPDM rubber rather than the continuous stainless lip seal of older machines, hardens and cracks, and the machine begins to weep. Bosch, frequently cited as one of the better dishwasher brands on the market, has faced class action litigation in federal court, alleging that known defects were present at the time of sale. This is not a fringe problem. This is the product category. And then there is the cleaning performance itself, which is, after all, the entire point of the machine. The old DOE energy test protocol that certifies dishwashers uses a standardized soil load, weighted toward light contamination. The machines are optimized to pass that test. But Consumer Reports clean cycle evaluations, which use real-world soil loads, consistently show that modern soil-sensing dishwashers perform below their advertised capability when presented with heavily soiled dishes. The soil sensor detects a light load, shortens the cycle, conserves water and energy, and leaves food on the plate. They call this intelligent sensing technology. We call it a machine that decides your dishes are clean enough and stops before the job is done. Now you understand what the machine is made of. The next question is why the repairman cannot save you when it breaks. The sealed component problem is by design. The control board is mounted in a proprietary housing that accepts only the manufacturer's replacement board. There is no generic equivalent. There is no aftermarket option. Some manufacturers require service technicians to access diagnostic functions through proprietary subscription applications. The repairman's access to the machine is controlled by the manufacturer's software. When the board fails out of warranty, which it almost always does, since the failure peak is between 42 and 48 months, and most warranties run 12 to 24 months for parts, you are buying a manufacturer-priced component at a manufacturer-controlled markup, installed by a manufacturer-certified technician at a rate the market cannot undercut, because the alternative parts simply do not exist. That is not a free market. That is a captive service economy built around a product that was engineered to create it. The warranty itself is structured to expire before the failure arrives, 1 to 2 years on parts, with labor often not covered beyond 90 days. The control board fails at year 3 to 4. The sump cracks at year 4 to 7. The math is not accidental, and 80% of those warranties, according to a review of manufacturer disclosures, include binding arbitration clauses that prevent class action litigation. Most homeowners who experience a $300 board failure on a $600 machine do not call a lawyer. They call the store and buy a new one. There is also the deeper problem of the vanishing repairman. The skilled appliance technician workforce is aging, and the trade is not attracting new entrants fast enough to replace those who are leaving. The knowledge of how to diagnose a dishwasher at the component level, not swap boards until something works, but actually diagnose, is retiring out of the industry. What you get instead, in many markets, is a service call where a technician who has been in the trade for 3 years shows up, reads the error code, and orders the most expensive board on the machine. If that fixes it, good. If it does not, he orders the next component. This is called parts cannoning. It is not incompetence. It is the logical response to machines that are too complex to diagnose cheaply on a single service call. So, if the machine is designed to die at 5 years, if the parts are priced to make repair economically irrational, if the warranty is written to expire before the failure, and if the technicians who could actually fix it are aging out of the field, what do? You stop buying the label and start buying the engineering. There are machines that are built differently, not many, but they exist. And the repairmen we spoke to know exactly which ones they are. The first name every experienced technician gives you is Miele. The German-made Miele G5000 series and the Miele G7000 series both carry stainless steel tub interiors as standard. Not as an upgrade, not as a marketing feature, but as the base specification. The control boards on Miele machines are rated to a higher thermal tolerance and are positioned away from the primary steam path. Longevity data and Miele's own engineering specifications point to operational lifespans of 15 to 20 years for well-maintained units. The machines are expensive. A Miele entry-level model begins around $1,100, but the total cost of ownership over 20 years, one purchase maintained, is lower than buying 3 $700 Energy Star machines at 5 to 7 year intervals. And Miele parts, while not cheap, are available through independent suppliers and are not locked behind firmware authentication. The second machine worth knowing about is the Bosch 300 series. Not because Bosch is without fault, but because among the mainstream brands, the Bosch 300 series uses a full stainless steel interior tub and a brushless motor with a longer rated duty cycle than most competitors at the same price point. It is not the premium recommendation. It is the acceptable compromise for the buyer who cannot spend Miele money and needs something that will last beyond the warranty period. The third recommendation, and this one will surprise people, is to look hard at the oldest functional dishwasher you can find. If you own a Maytag, a Kenmore, or a KitchenAid from before 2006, with a mechanical timer and a stainless tub and a cast pump, and it is still washing dishes, you are holding an asset. That machine is worth $300 in maintenance. It is worth a new door gasket, a new pump seal, and a descaling service. It is not worth replacing. The machine you will buy to replace it will outlast it in showroom photographs, and nowhere else. The rule that experienced repairmen apply to their own homes is this: fewer features equal longer life. Every sensor is a failure point. Every circuit board is a ticking clock. Every plastic housing is a future leak. The best dishwasher for your kitchen is the one with the most metal, the fewest screens, and the simplest control system you can buy today. If the salesman is pointing to the Wi-Fi app and the soil detection algorithm, walk toward the machine with the dial. Here is the verdict. 90% of new dishwashers are certified efficient and designed disposable. The Energy Star label measures what the machine consumes per cycle. It does not measure how many cycles the machine will complete before it dies on your kitchen floor. A machine that uses 4 gallons per cycle and fails in 6 years is not environmentally responsible. It is a 6-year rental dressed up as a purchase. Stop buying the sticker. Buy the steel tub. Buy the mechanical simplicity. Buy the machine the repairman puts in his own kitchen. The most expensive dishwasher in the world is the one you replace 3 times in 20 years. The cheapest one is the one you buy once and run until the wheels fall off. Buy the machine that was built to be fixed. Reject the machine that was built to be replaced. The most expensive words in the modern kitchen are 5 of them. It is not worth fixing. Do not let them apply to your machine.